Included in the National Blend of Models version 3 are a number of weather grid elements and inputs to create a weather grid in GFE. Some of those inputs are defined, or fields are shown on the left-hand side here. The Burgoyne positive and negative energy, probability of ice present in the column, probability of rain, snow, freezing rain, and sleet, and also the probability of refreezing to sleet. A few other fields also included in NBM version 3 are the snow to liquid ratio, snow level, and the probability of thunder. Along the top part of this chart, you can see some of the model inputs that are going into creating these fields. These are the short-term guidance values or models. And for the extended range, we have obviously a less intense data set and less input members for those outer ranges of the NBM. But all these inputs are combined together to provide a forecast grid for weather, snow amount, and ice accumulation when the fields are combined with software on GFE to create those grids. So an overarching workflow design that was created by a team of SUs in the 2016-2017 period for the NBM version 3 takes the NBM weather input grids that I just discussed and the raw precipitation type probabilities, which are conditional, and the NBM creates those on WCOS, and those are transmitted via the SBN and will be available in AWIPS version 17.2.1. But the idea is that these NBM grids are delivered to the WFO, and then the WFO can ingest those into GFE. And the adjustment based on current weather, especially in the short term, is available in GFE. To the ability and methodology to adjust those grids is available in GFE, and then a rederivation can occur of the probabilities after adjustment of the input grids, and then we rederive and publish our weather, snow amount, and ice accumulation. One of the toolboxes in GFE, if you want to call that the front end, one of the toolboxes there and front-end software platforms is the forecast builder, which takes these probabilities and input grids, even if they're edited at the local level, and rederives precipitation type probabilities and uses other inputs to come away with weather, snow amount, and ice accumulation. So let's take one more step in detail, briefly just kind of describe what happens in that weather creation step. The NBM grids are created on WCOS via all the model inputs that are associated with the NBM. And these different variables are calculated for each model or model member within the NBM. So we pick out the max temperature aloft for each of those members, and then that is a mean is created from those member inputs. And then we have our blended environmental inputs that then lead to the calculation of the probabilities. Those probabilities are calculated using the top-down methodology and probability of weather type infrastructure after myself, Dan Baumgart, Bob Rauber, some of his work in 2001 and his data, and also from Andy Just and his GFE infrastructure of probability of weather type. So these conditional probabilities are then created from the blended environmental inputs at the NBM level and transmitted on the SBN. So taking that structure that we just talked about here, those inputs and probabilities, at the local WFO level, we see this box here on the lower half of the slide. From those inputs, we can take the QPF and parse it out into different types. Multiply the QPF that's going into snow by the snow ratio and come away with a snow amount. Using a IP ratio or a pellet ratio of 2:1, we can do the same thing for sleet and come up with a sleet amount and add that into the snow amount. And the same thing for freezing rain, where we used the freezing rain accumulation model by Sanders and Bargenbrook in 2016. We put the QPF for freezing rain through temperature and dew point analysis and come away with an ice accumulation. All of these combine then to also build a weather grid. And this is done right now, at least one of the techniques is to use the forecast builder infrastructure to create these final grids. So what happens at the local level when some of that information does not look consistent with the observations? Well, the WFO level forecaster can come in here, or the WPC, or whatever the National Collaborative Forecaster desires, can edit these blended environmental inputs and then move into the rederivation of those probabilities, which is automated. It doesn't have a bias that the forecaster may build into it, and it also keeps the data set consistent with temperature and dew point, scientifically and internally consistent with the temperature and dew point fields. And then we can rederive the lower portion via forecast builder. This entire infrastructure or this entire flow chart here is completed and available to be completed within the GFE forecast builder tool set. So it allows local adaptation, local adjustments when the NBM delivered information is not consistent with the current weather scenario that is ongoing. So the precipitation types briefly are based on the top-down approach, as I mentioned earlier. The forecast builder and NBM derivation of the precipitation types are exactly the same. So we are talking about consistency both from a national delivered level if you use the precipitation types directly, or rederive them in the forecast builder without altering the inputs. Also, new to the forecast builder infrastructure at least is the inclusion of snow level, which can also be used to diagnose the precipitation type, especially in areas of terrain, but any site can use the snow level via the forecast builder. And again, the forecast builder is designed to ingest those NBM weather grid environmental inputs as a front-end tool for the forecaster as a starting point, and then local modification of the inputs can occur with a rederivation of the type probabilities as needed using those GFE tools. One final field that is included in the NBM version 3 is the probability of thunder, and currently that is not a quote-unquote blended field. Right now the SREF is used in the short term, and the SPC 3-hour calibrated probability of thunder is used, and in a technique that's very similar to the SPC technique that's calculated on W costs. Those values should look very similar to those found on the SPC SREF page. And also the GMOS is then used at ranges greater than the SREF forecast length. The GMOS 6-hour calibrated thunder probability is used in the NBM grid at this time. More work is being done on the probability of thunder and will be improved in the following NBM build upgrades. Reference material, we have quite a bit out there for you. This is simply an introduction video here, but I would recommend that you download this PowerPoint and look at some of these different links that are available. Here in the training area, we have a forecast builder training plan that talks about the GFE tool set that's available. There's also a Commerce Learning Center curriculum on the forecast builder. And then there's a series of videos, including a top-down precipitation type review, the freezing rain accumulation model, and some of the probability of weather type tools that are within the GFE infrastructure. But those are all videos that were created to help the training effort. And then just detailed documentation on all of the NBM environmental inputs, precipitation types, and how snow and ice accumulation are created can be found in this forecast builder document in the appendix A and B. There's also an AMS 2017 annual meeting poster that you can download and take a look at that was presented on this technique. And one final note, just a recommendation to join the VLab National Blend of Models community. This is where the clearinghouse for information on the National Blend of Models resides, and also where this PowerPoint will be posted for your use.